Hi, this video is going to cover section 7.2, which is applications of the normal distribution. Right. So if you recall in the last section, what we looked at was having continuous random variables, and we looked at the idea of having a normal curve, a graph of a normal curve. We looked at some properties of a normal curve, and then we also looked at interpreting the area under the curve as a probability, right? Or a proportion of that population that fits in that category, right? We looked at that in section 7.1. So in section 7.2, what we're shifting gears to, this section is mostly going to be about how to calculate the area under the normal curve, right? So I told you in the last section, really the way to do that is you have an equation, a function. We call it the PDF, if you remember, the probability density function. But that equation for a normal function is beyond the scope of this class, right? It deals with it's an exponential function, which we're not going to deal with. And then also you need to use what we call integral calculus, which you would take in calculus 2, to find the area under a curve, right? So we use an integral to do that. But again, that's beyond the scope of this class, right? I'm assuming in this class that you have a decent understanding of algebra, right? Not necessarily have taken calculus, right? So what we'll be doing is using Statcrunch or a table in order to find that area under the curve, right? So then when you're using the table in the textbook, it's table 5 in appendix A, you'll notice that in the table we're going to have to convert everything into z-scores, right? So rather than having a bunch of different tables with different means and standard deviations, right, that's really hard to do. We can put everything into the standard score, z-score, right, like we've looked at before, right? So remember, with a standard normal distribution or z-scores, the mean is 0 and the standard deviation is 1, right? So then, looking at this next paragraph, I say that we can use the notation, so capital N, and then in parentheses I have mu, comma, sigma, right? So in other words, this is notation that you can use to show that you have a normal distribution. The capital N applies to the normal distribution, and then in parentheses the first number is going to be the mean and the second number is standard deviation, right? So for example, if we have a standard normal distribution, that's a notation that we use to describe that distribution, right? So the mean is 0, standard deviation is 1. And then here in the green box, I put this here to remind you of the equation for calculating z-scores. So we'll need to be able to do that, right? And then also in table 5, something else that you need to note, right? So first is that everything's in terms of z-scores. So we have to, if you're given like an x value, we need to convert it into a standard score, z-score. And then also in the table, we're always finding area to the left of that z value, right? So in the table, it's always area to the left. Right, so let's try an example. So example 1, we're finding the area of the standard normal curve that lies to the left of z equals negative 2.45. So the very first thing that we want to do is graph the standard normal curve and shade the area, right, that we're finding, right? So here's my z-axis, right in the center is going to be the mean, which is 0 in this case for z, and then negative 2.45 will be somewhere to the left here. So negative 2.45, and we're finding the area to the left of this, so that would be this area, right, that we're finding. And notice that I labeled where the mean is in the center, and I like to do this as a reference point, right, so that way I know where to draw the particular z or x value. right? So then in part B, we want to find this area in Statcrunch. So let me open up Statcrunch. Right, so to find this, you're going to go to underneath the stat menu and then calculator. And then remember, we used the binomial in the last chapter, so we need to go down to the normal calculator. Right, so just go down to normal. And then here, it's going to work similar to the binomial. Right, we can change some different values in here and hit compute. It'll give us the area and the graph. Right, and I can also hit the between button if I'm between two values. Right, so it looks pretty similar. So for this, we're using z-scores, so the mean should be 0, the standard deviation is 1, and then so I'm wanting less than or equal to, and then it's negative 2.45, right? And then I hit compute, and you can see here's the graph. We're finding that red area, and this value listed here is the actual area, right, or the probability. So we can write that down, right? So the probability that z is less than or equal to negative 2.45 is equal to 0.0071, right? And so now we want to practice using the table, right? So we're finding area to the left, so using the table isn't too bad for this, right? So you can find the table in Appendix A in the textbook, or I posted a PDF, this PDF document, and with these notes as well, right? So let me teach you how to read the table. So this first page is for negative z-scores, and then the next page is for positive z-scores, right? So we want negative 2.45, right? So with this table, it only gives all the z-scores are to 2 decimal spots, right? So first you're going to find negative 2.4, right? So you're going to find that here. So my value is going to be somewhere in this row. And then you'll notice across the columns, those values there are the hundredths decimal spot, right? So my number is 2.45, so I found negative 2.4, and then I need to find the 0.05 column, right? So right in here, this column, where they intersect is the value I'm looking for, right? So I'll circle that in red. So I was looking for that value, which is 0.0071, right? So that's the area to the left of the z-score of negative 2.45, right? And that's what we're looking for. Right, so the probability that z is less than or equal to negative 2.45 is equal to 0.0071. Right, we're getting the same value in the table. Right, and something we'll find is that these values don't always match. Using technology is going to be more accurate. Right, so then example 2. Similarly, we're finding the area to the left of the z value, but our z value here is negative 45, right? So that's a really small z value, and I did this intentional so we can look at a phenomenon that's addressed in the textbook. So I'm listing the mean here at 0, right? This is my z-axis. So then z of negative 45, would be way over here, and we're finding this area, right? That area is equal to the probability that z is less than or equal to negative 45, right? So first thing we want to do is find the area using Statcrunch. Right, so if I use my normal calculator again, we want z less than or equal to negative 45, right? And the mean and standard deviation stay the same because we're dealing with z-scores. I hit compute, and notice the area that it's giving me is 0, right? So the probability that z is less than or equal to negative 45 is equal to 0, right, as given by Statcrunch, right? But something that we have to keep in mind is that that's not exactly equal to 0, right? It's going to be super small, basically 0. But the only time that a probability, an interval of the area is going to be equal to 0 on this curve is if you have the same two values, right? So for example, if I ask you to find the probability that z is in between 10 and 10, right? If those two numbers match, then that's going to be exactly equal to 0, right? So the probability that z is less than or equal to negative 45, this is going to be practically 0, right? There's going to be a bunch of zeros in here, right, in between, and then there's going to be some numbers at the end, right? But it's not going to be exactly equal to 0. So it's basically equal to 0, right? So oftentimes what we'll say is that in this case the probability is less than or equal to 0.0001. Right, so typically with finding probability under a curve, we go out to 4 decimal spots, right? That's pretty typical. So all I really care about is that this area is less than 0.0001, right? So that's pretty typical, right? Whoops, I should just do a less than there. Less than or equal to would be okay, but we don't need the equal to part. Right. So again, this is just an idea just to think about, that sometimes your calculator might, calculator or statistical software might give you a value of 0 when it's not actually 0, but it's basically 0, right? If that makes sense. So then the next part, I say, can the area under the curve be equal to 1, right? So the area under the curve, from negative infinity to infinity is equal to 1, right? That would be the only case that would be equal to 1. However, similarly to the 0 thing, sometimes if the value is really large, right, really close to 1, Statcrunch might just say it's equal to 1. Right, so for example, if you look at finding the probability between negative 45 and 45, right, so find the probability that z is in between negative 45 and 45, you're going to find that this is going to give us 1, right? So we can verify that. So if I hit the between button here in Statcrunch and change this to be negative 45 to 45 and hit compute, notice it gives me 1, right? Because it basically is 1, right? But it turns out that that's not going to be exactly equal to 1, right? So Statcrunch. But it's going to be basically 1, right? So typically what we would say is that if you find the probability between negative 45 and 45, for example, this would be greater than 0.9999, right? So this is, more correct than being equal to 1. Right, so these are just some ideas just to be aware of. Right, so the next example, example 3, this time we're finding area to the right. Right, so it says find the area of the standard normal curve that lies to the right of z equals negative 3.49. Right, so if I want to draw a graph of this, there's my z-axis. In the center, we have z of 0, and negative 3.49 would be somewhere over here. And we're finding the area to the right. So we get this, right? So again, that area is equal to the probability that z is greater than or equal to negative 3.49. Right? So we can find that area using Statcrunch. So we would write negative 3.49. Whoops, we want to do standard, right? Less than negative, or no, greater than 3.49. Right, and mean standard deviation stay the same because we have z-scores. So there's the graph, and here is the area, right, the probability. So this is equal to 0. So if I round to 4 decimal places, 0.998, right? So really large, right? Almost 1. So now we need to think about part C, how to do this with a table, right? So remember, the table is always going to find the area to the left, right? So the basic idea, and I'll shade this in blue, right? So this blue area is the probability that z is less than or equal to negative 3.49, right? So this part in blue we can look up in the table, right? We can look that up in the table because the table goes to the area to the left, right? So it's always finding area to the left, right? But then if we think about it, this blue area, right? So the blue area plus the red area, right, are going to be equal to 1, right? If we use this phenomena, right, because these are complements of each other, right, using the complement rule, right, what we can find out and calculate from this is that if I take the probability of z greater than or equal to negative 3.49, this is going to be equal to 1 minus the probability that z is less than or equal to negative 3.49. Right? So if you want to find area to the right of a value, you're just going to take 1 minus the area to the left, right? Because the total area of the curve has to equal 1 or 100%, right? So that's the basic idea of this. So in this value, we can look up, right, in the table. So if I go back to my table, let me go ahead and erase this, right? So I'm going to want to locate negative 3.49 on the table. So negative 3.4 would be this row here, and we're looking for this column. So the value I'm looking for is this here where I circled in red, right? 0.0002. So if I go back into the notes, right, we can just plug that in. So this would be equal to 1 minus 0.0002, which subtracting those gives me 0.9998. Right, so we get the same value using Statcrunch, right, rounded to 4 decimal places. Right, so example 4 is similar, finding area to the right. So we have z equals 2.23, right? So if we want to draw this curve, then 2.23 would be somewhere over here, right? So I want to locate the area to the right, which would be this area, right, that shade. So the probability that z is greater than or equal to 2.23, right, we can find with Statcrunch. So we change this to be 2.23, hit compute, and we get the area there. Right, so rounding that to 4 decimal places, we get 0.0129. Right? So then using the table, similar to before, what we're going to want to do is take 1 minus the probability to the left. right, if you want to use the table. Because again, I can look up the area to the left in the table, because it always goes to the left. Right, so I have a positive value, so I need to go to the second page this time. And we want 2.23, so I'm going to locate 2.2 in the first column. Right, I'm looking in this row, and then I'm looking for the 0.03 column, because that's my second decimal spot, my hundredths place value. Right, and then where they intersect is the value I need, right? 0.9871. So this would be 1 minus 0.9871, which equals 0.0129. Right. All right, so the first couple examples we looked at finding area to the left, and then in these last two we looked at finding area to the right. Now what's left is finding area in between, right, in the middle. So like in example 5, it says to draw the area of the standard normal curve that lies, or finding the area between the standard normal curve that lies between z equals negative 2.04 and positive 2.04. So we want to draw this situation, right? So if I draw this, I got my z-axis, I got the normal bell-shaped curve. In the center is going to be a z-score of 0, and then somewhere over here would be negative 2.04, and then somewhere over here would be positive 2.04, right? What I'm after is the area in between these values. So this part here in green, right? So I want to find the probability that z is in between negative 2.04 and positive 2.04, right? That's what I'm after. So I can use Statcrunch to find that area. I just need to hit the between button, and then my mean and standard deviation stay because it's z-score, right? So mean's 0, standard deviation's 1. I'm finding the area in between negative 2.04 and positive 2.04. So if I hit compute, I get that area there, right? And I get the nice graph. So if I come over here, to 4 decimal places, this is 0.9586. Right, writing that to 4 decimal spots. Right. So now here's maybe a little trickier part, is how to calculate this in the table, right? Because what you have to remember is that the values in the table always go to the left, right? So the basic idea is the following, right? So if I look up this value in the table, what it's going to give me is it's going to give me the screen area plus this area I'm shading in blue here, this tail here. Right? It's going to give me all of this, right? Except the problem is I don't want this part. I don't want. I need to get rid of that, right? So what that would be, this blue area would be the probability that z is less than or equal to negative 2.04, right? So the whole area to the left of 2.04 would be the probability that z is less than or equal to 2.04. And then, the area I want to subtract or get rid of is the area to the left of my smaller value, right? So the basic idea is if I want to find the probability that z is in between negative 2.04 and positive 2.04, what you're going to do is this is going to be equal to the probability that z is less than or equal to your bigger number minus the probability that z is less than or equal to your smaller number, right? Negative 2.04. Right? So the subtraction part is getting rid of that tail area that we don't want. Right? That's included in this first calculation. So I can look up both of these values in the table. right? So I've shown you how to do that a few times. So I think you're probably good to be able to look those up in the table. So I'll just go ahead and write them down, right? So this first one would be 0.9793, and the probability that z is less than or equal to negative 2.04 is 0.0207, right? So subtracting those, we get 0.9586. All right. So I have another example of this for between. So we're finding the area in between z equals negative 3.03 and z equals 1.98, right? So first let's draw this. Right, so in the center is 0. Over here to the left would be negative 3.03 somewhere, and then somewhere to the right of 0 would be this 1.98 value. And I'm finding the area in between these. Right. So again, using Statcrunch, my mean's still 0, standard deviation's still 1. What's changing are these two z-scores. So the first one's a negative 3.03. It's a smaller one. I'm finding the area between that and 1.98. Right, hit compute, and we get the area. Right, it's about 0.97. Right, so the probability that z is less than or equal to negative 3.03 and 1.98 comes out to be 0.9749, rounded to 4 decimal spots. So then if we're trying to find that area using the table, right, again, the basic idea is if I start from here, if I plug in, if I look up in the table z less than or equal to 1.98, right, that's going to give me the area all the way to the left, right, except from here on, I want to delete. Right, I don't want that area. Right, I need to subtract that out. Right, so that part is the probability that z is less than or equal to negative 3.03. Right, this smaller value. Right, so I can look up both of those values in the table. Right, because they're both areas to the left. So if I subtract those two, I get the area I want. Right, which is in green. So the probability that z is in between negative 3.03 and 1.98 is equal to the probability that z is less than or equal to 1.98 minus the probability that z is less than or equal to negative 3.03. Right, so if you look up both of those values in the table, the first one is 0.9761, and the second value in the table is 0.0012. Right, subtracting those, you should get 0.9749. Right, so we've dealt a lot with the standard normal curve. Right, that's where we're using the z-axis. Now we want to switch gears a little bit to where we're given a mean and standard deviation that's different than 0 and 1. Right. So before I do this, I just want to scroll down the top of the next page and just point this out. Right, it says for any continuous random variable, the probability of observing a specific value of the random variable is 0. So for example, for a normal random variable, p of a is equal to 0 for any single value of a, because there's no area under the normal curve associated with a single value. Right? Therefore, the following probabilities are equivalent. Right? So we looked at before, with a continuous random variable, if I find the probability at a specific value, that probability is always 0. Right? And that's why we always look at like an interval of values. Right? So what this is saying is that when you find the probability, it doesn't matter if you include that value or not, right? So in other words, like if I look at my next example, if I look at the probability that x is greater than 65, that's the same thing as the probability that x is greater than or equal to 65. right? So I can use greater than or equal to. In other words, I can include 65 or not, and the area doesn't matter, right? So that's true for continuous random variables. However, for discrete random variables in Chapter 6, that makes a big difference, right? Or at least it could, depending on what the probability is at that particular value. But it definitely matters, right, for discrete. Right? So to be able to find the normal, to be able to find this area, right, first let's draw the normal curve. So I'm going to draw two axes on here. I'm going to label this as x and then z, right? We're going to use them both here in a moment, right? So I'm going to draw my standard normal curve here. In the center is going to be my mean, which we're told that mu equals 50, right? The mean equals 50, right? So mean equals 50. Standard deviation is 7, right? We're told that in the problem. So what we're trying to find is what's the probability that x is greater than 65, right? So the mean is going to be in the center here. 65 is going to be somewhere over here, right? And both of these are x values, right? They're values from the random variable. And I can shade this, right? So I'm finding the area to the right because we're looking for x greater than 65, right? So this area is equal to the probability that x is greater than 65, right? Which is also equal to the probability that x is greater than or equal to 65, right? Both of those would be the same. So if I want to use table 5 as stated, right, to do next, you're going to have to convert everything into a z-score, right, in order to do that. So remember, the equation for z is x minus the mean divided by the standard deviation, right? So if we plug these in, right, we're looking at an x value of 65, the mean is 50, and the standard deviation is 7, right? So this equals, what, 15 over 7? And if you remember from the table, all the z-scores only go out to 2 decimal spots, right? So if I round this to 2 decimals, I get 2.14, right? So this is a rounded value, right? So in other words, what we're finding is that the probability that x is greater than 65 is the same thing as calculating the probability that z is greater than 2.14, right? So notice I changed my variables, right? So I had to change the value associated with that, right? It's almost like changing the units, if you will, right? So if that makes sense, right? So so on this z-axis, right, I didn't label anything yet, but lining up with 50 would be a z-score of 0, right? Because 0 is right at the mean. So then the z-score associated with 65 would be this 2.14 value, right? Right, so I can find this value from the table, right? Well, I can't find greater than, right? I need to find to the left less than, right? So we need to use our trick, right, for finding area to the right. You're going to take 1 minus the area of the left, right? So now that z value less than 2.14 I can find in the table, right, that we've been doing. So this would be 1 minus 0.9838, right? So that's the value from that table. And if I subtract those two numbers, I get 0.0162. Right, so now we can do this using Statcrunch. So in this case, I don't have to convert any z-scores, right? I can just plug in a mean of 50, a standard deviation of 7, and then we're not finding between, so I need to click on standard. We're finding that x is greater than or equal to 65. Right, if I hit compute, I get this area, right? So notice I didn't have to do any conversion to z-scores, right? So that makes Statcrunch nice, right? So the probability that x is greater than or equal to 65 is equal to 0.0161, right? And that's rounding to 4 decimal places, right? And you want to notice that this value and this value are a little off, right? And that's because remember, using technology is going to be more accurate because we didn't have to convert to a z-score and round it all, right? Because remember, the z-score is actually equal to 15/7, but we had to round that to 2 decimal places in order to be able to look that up in the table, right? So technology is going to be more accurate, and that's why they're a little off because of rounding error, right? So that's expected. Right? So then the next example, example 8, right? So we still have the same setup in the sense that the mean is equal to 50, the standard deviation equal to 7, right? I'm trying to find the area to the left of 45 essentially, right? So if I draw this normal curve, right in the center is going to be line up with a mean of 50, right? If this is my x-axis. So then 45 is going to be somewhere to the left, and I'm finding the area to the left of 45. Right? So just like before, I can draw another axis underneath the x-axis and call this the z-axis, and I can label this. So what's lined up with 50 would be a z-score of 0, and what's lined up with 45 is a z-score we don't know, right? We need to figure that out. So z is equal to x minus the mean divided by the standard deviation, right? So this would be equal to 45 minus 50 all over 7, which is -5/7, right? So again, I need to round that to 2 decimal places so I can look it up in the table. So this would be approximately equal to -0.71. Right? So I could look that value up directly in the table. So the probability that x is less than or equal to 45 is going to be equal to the probability that x is less than or equal to -0.71. I can look that up in the table, and it's going to the left, so I don't have to worry about changing that at all, right? The value that's in the table is 0.2389. And of course, if we want to use Statcrunch, so the mean standard deviation is the same as example 7. So I just need to change this to be less than, and we wanted less than 45. Right now I can hit compute, and I get the area, right? And so that matches up with the table, right? So the probability that x is less than or equal to 45 is equal to 0.2375. All right, so then the next example I have, so we already went over this top part of this page, right? So the next example, example 9, we're finding area in between, right? So I have this, so let me draw my graph, right? So right in the center is going to be my mean, which is 50, and then somewhere to the left of 50 is going to be 38, and then somewhere to the right of 50 is going to be 55. And I'm finding this area in between these values, right? That's what I'm after. So again, I can't just plug these in to the table, right? Because everything needs to be in terms of z-scores, right? This is in terms of x, right? My variable, my random variable. So if I draw an axis underneath, this could be my z-axis. What lines up with 50 is 0, and I don't know the value that lines up with 38 and 55. Right? So I can figure that out. So for 38, we would have z equals 38 minus 50 divided by 7. right? And this comes out to be negative 12/7, which is approximately equal to negative 1.71, right? So rounding to 2 decimal spots, right? So that's my z-score for x equals 38, right? So for x equals 55, the z-score would be 55 minus 50 all over 7, which is equal to 5/7, which is approximately equal to 0.71, right, to 2 decimal spots, right? So what we have is that the probability that x is in between 38 and 55 is going to be equal to the probability that z is in between negative 1.71 and 0.71, right? And then so we have to do our little trick here that we did with the z-scores, right? So remember what the trick is we find the area to the left of the bigger value, right, minus the probability to the left of the smaller value. So I can look up both of those values. Oops, wrote down the wrong number here. This would be negative 1.71. Right, so I can look up both of these values in the table, and what you should get is 0.7611 for the first, and then for the second one 0.0436. And then so if you subtract those, you get 0.7175. Right? So then if you want to use Statcrunch, we need to hit between. The mean still 50, standard deviation still 7. The values that were in between are 38 and 55. Hit compute, and we get that value, right? And notice it's a little bit different than using the table, but again, that's expected from rounding error. Right, so we get 0.7192. Right, so then example 10 says the length of human pregnancies are approximately normally distributed with mean equals 266 days and standard deviation 16 days. What proportion of pregnancies lasts more than 270 days? Right, so I would start by drawing a curve, and the center is going to be the mean, which is 266 days. And then somewhere to the right of that is going to be 270. And I'm finding the area to the right, right? We want it to last more than 270. So in other words, we're finding the probability that x is greater than or equal to 270. Right? So I can get that value pretty easy using Statcrunch. So my mean is 266. Standard deviation is 16. We need to switch over to standard. We need this to be greater than and 270, right? Hit compute, and we get that area, right? So this probability is equal to 0.4013. Right, so the next one, what proportion of pregnancies last less than 250 days, right? So again, just start by drawing my normal curve, and the center is the mean, 266, so that gives me a reference point to know that 250 is going to be somewhere over here, and I'm looking for this area, right? So the probability that x is less than or equal to 250 is going to be equal to so we can find this using Statcrunch. We want 250. Right, we get that value. So rounding to 4 decimal places, it's 0.1587. Right? So then, let me erase this for a moment. I've written over top of that. So that was 250. So in part C, we're finding, what proportion of pregnancies last between 240 and 280 days, right? Right, so there's my mean. So 240 is going to be somewhere to the left, and 280 somewhere to the right. So I need to find this area here. That's what I'm trying to find. So the probability that x is in between 240 and 280 days, we can find using Statcrunch, right? So I hit the between. My mean deviation is the same. So this would be between 240 and 280. And we get the area and a nice graph. Right? So that was 0.7571. Part D says, what is the probability that a randomly selected pregnancy lasts more than 280 days? Right? So we're trying to find what's the probability that x is greater than or equal to 280, right? That lasts more than 280 days. So the picture, right, would look like this, where in the center here is the mean of 266, 280 would be somewhere over here, and we're trying to find the area of this right tail, right? So if you plug that into Statcrunch, you should get 0.1908. Right? Part E says, what's the probability that randomly selected pregnancy lasts no more than 245 days? Right? So that would be finding the probability that x is less than or equal to 245. Right? Or in other words, if you want to draw the normal distribution, we would be trying to find this area, right? So again, using Statcrunch for this, you should get 0.0947, right, for the area. Right. So part F says a very preterm baby is one whose gestation period is less than 224 days. Are very preterm babies unusual? Right. So remember, probability is less than 0.05. We consider to be unusual, right? So if we start just drawing a picture really quick. In the center would be 266 days, and then over here would be 224. I want to find this area less than, right? So the probability that x is less than or equal to 224, right, using Statcrunch like we've been doing, this is equal to 0.0043, right? So this number is clearly less than 0.05. So we would say, yes, it is unusual, right? Where remember, if that would be greater than 0.05, it wouldn't be that unusual. All right, so objective 2 is kind of doing the opposite, right? So sometimes we might be given an area and we want to find the particular z or x value that corresponds with that particular proportion, probability, or percentile, right? So it's working a little backwards, right? So we know the area and we're trying to find like that cutoff value. So like for example 11, it says find the z-scores such that the area under the standard normal curve to its left is 0.2. Right? So in other words, if I draw a picture, we're dealing with z-score, so in the center is going to be a z-score of 0, and my area is going to be 0.2, which is less than 0.5, so I know it's going to be somewhere on the left here, right? So this area equals 0.2, and I want to find what's the z-score that corresponds with that, right? So you can use Statcrunch to find this same calculator, right? So if I go back to the standard, right? So what I'm going to do is type in a mean of 0, a standard deviation of 1, and that's because we're dealing with z-scores, standard normal. And then I'm going to keep this as less than because we're finding area to the left. And then here I'm going to delete this 250, right? I'm going to leave this box empty. And instead, in the equal spot, I'm going to put in the area I want, which is 0.2. And if I hit compute, it's going to fill in the value in this box now, right? Which is what I want. I hit compute. So that is the z-score, right? So if I round this to 2 decimal spots, right, we get that z is equal to negative 0.84, right? So it's pretty slick how that works. Right? So part B says find the z-score such that the area under the standard normal curve to its right is 0.35. Right, so again we're going to have a a standard normal distribution here with a 0 in the center for z-score of 0, and then since my area to the right is equal to 0.35, I know that it's going to be somewhere over here, right? Because remember, right in the center, right from here over is 50%, right? So that's how I know it's got to be to the right of the mean. So this would be some z-score. We don't know. We need to find it. So I can do the same thing in Statcrunch. I need to delete what's in this box, right? And then I need to change this to be greater than or equal to, since I'm finding an area to the right, right? And I want this area to be 0.39. Or not 0.39, 0.35. Right? And if I hit compute, I get an answer of 0.39. Right? That's what the z-score would be, roughly to 2 decimal spots. So z is equal to 0.39. So then part C says find z-scores that separate the middle 99% of the distribution from the area and the tails of the standard normal distribution, right? So if I draw a picture, the situation that we're looking for is here's z-scores, right in the center here's a z-score of 0. What I want to do is find a negative z and a z value where this middle area is equal to 0.99, right? 99%. So I need to find those two values. Right, so to do this, we can hit the between button, right? And it will work pretty similar, right? The mean would be 0, standard deviation is 1. I need to delete these in-between values and type in the in-between area to be 0.99. And I can hit compute, and I get those two values. Right? So the two z-scores is negative 2.58 and positive 2.58. Those are the two values that I wanted. Right? All right. So example 12 is we're assuming the random variable x is normally distributed with a mean of 50 and standard deviation of 7. We want to find the 81st percentile, right? So remember what percentile means, right? So if I draw my standard normal distribution, I'm going to have a mean here of 0, right? Z-score of 0, and then there's going to be some x score over here where well, and this would, I'm saying I'm labeling this x, right? But really this would be really this should be, I'll put this as 50, right? How about that? So I'll leave this as the x-axis, right? So right in the center is going to be my mean of 50, and I drew some value here, and what I'm looking for is I want this area to be 0.81. Right, because remember percentile means if I'm in the 81st percentile, it means that 81% of the population is behind me, right? If we put everyone in order from smallest to biggest, right? So this could be like test scores, height, etc. right? So we can use Statcrunch to find that value. So I need to go back to the standard. My mean was 50, standard deviation was 7, and I want this to be less than or equal to, and then I can make this be, I need to delete this, and in the area I need to put 0.81, hit compute, and it will give me that value here, right? So the answer is 56.15. We rounded 2 decimal spots. Right, so in this case, x was equal to 56.15. Right, that's the value here, that cutoff value. So we found the line in the sand where 81% of the area to the left is 0.81. All right, so example 13 is the reading speeds of 6th grade students is approximately normal with a mean speed of 125 words per minute and a standard deviation of 24 words per minute. Right, so part A says, what is the reading speed of a 6th grader whose reading speed is at the 90th percentile? Right, so if we draw a picture, right in the center would be the mean, which is 125 words per minute. And we want 90th percentile, right? So I'm going to have some, x value over here where this area is equal to 0.9. Right? That's what I want to find. I want to find that x value. So if I use Statcrunch, I need to change the mean to be 125. The standard deviation was 24. And we want less than, right? We're finding area to the left. And the area we want to be 0.9. So I type in 0.9 here, hit compute, and that gives me the reading score, right? And, probably these reading scores are given rounded to the nearest whole number, right? So if we round that, that would be 156. Right, so x equals 156. So the reading speed at someone at the 90th percentile would be 156 words per minute. So then part B says a school psychologist wants to determine the reading rates for unusual students, both slow and fast. Determine the reading rates of the middle 95% of all the 6th grade students, right? So if I draw my picture, and the center is going to be the mean of 125, and I want to find these particular cutoff values, I'll call x sub 1 and x sub 2, where the area in between this area is equal to 0.95. Right? So if I pull over Statcrunch, I'm going to hit the between button. The mean's still 125, the standard deviation is still 24. I need to delete these scores here, and then the area in between, we want that to be 0.95. Right? Hit compute. Oops, let me delete that. Hit compute, and I get those two values. Right? So this left value is roughly 78, and the right value that would round to be 172. Right? So this score here is roughly 78, rounded to the nearest whole number, and this value is 172. Right, so we'd want to be in between those two values for unusual, to be usual, right? So in other words, the unusual values would be this part in the green, right? So we found those lines in the sand, so we know how to identify the unusual values, right? These are the cutoffs. Right, so the green part are the unusual values. Right. So the last thing that I want to talk about is some notation that we'll use later on. So the notation z sub alpha is the z-score where the area under the standard normal curve to the right of z sub alpha is equal to alpha. Right. So in other words, we have a picture here, figure 29. If you're trying to find z sub alpha, that's this cutoff where the area to the right of it is equal to alpha, right? So let's practice finding these values. So the first one, part A, we're trying to find z sub 0.01, right? So if I draw a picture of this, right, I want to find this cutoff, z sub 0.01, which means the area to the right of this area is equal to 0.01. Right, so using Statcrunch, we'd go back to standard. I would have a mean of 0, a standard deviation of 1, right, because we're dealing with z-scores. And then I would want this to be greater than, right, because I'm finding area to the right. And then the area I want to be is 0.01, right? So if I hit compute, I get a z-score roughly 2.33 if I rounded 2 decimal spots. Right? So this is equal to 2.33. Right? So then finding the next area, or the next z sub 0.025, right? So this would be the z-axis, right in the center would be z-score of 0, and somewhere over here would be a z-score of 0.025. Right? So, and I want this, to find this value, I want this area to be equal to 0.025. So I need to figure out what that cutoff score is, right? So I'll go back to Statcrunch. I'm going to, again, delete this value here. And the area I'm going to put in 0.025, hit compute, and I get a z-score of approximately 1.96. Right? So this is equal to 1.96. So I rounded 2 decimal spots. All right. All right. So that's all I have for this section. Let me know if you have any questions. Thanks.